from a frozen section. I put them in the water. These are deionized water, just because if I were to leave them out on the tray, they would basically be virtually unmanageable. So the water is at 60 degrees C, plus or minus, usually plus a degree or so. Leave it in for 60 seconds. At least. Kinda. Well, when it first comes out, and some of it is really badly curled. The problem is this is really a job for a person with younger eyes. I've got my close glasses on. All you try and do is grab it in the corner. This way you can float it in the water, stratum corneum side up. It's very hard to see. So you float it over. You let the water out of the cell, or at least out of the initial receptor chamber. Get the rest of the water out of the chamber. Probably curl that right toward me.
So then you try and get it spread out flat. And now you're filling.
The reason being is that time what happened is you can see that it starts to get sucked in. Now it's pretty flat. Wow.
What's wrong?
Well, we're double. I just looked inside the donor chamber that was supposed to have been rinsed, and I see soil in there.
Yeah, well, we need to change this water.
Wow. I mean, that's unacceptable. I rinsed it. I thought he rinsed it. Oh. Well, oh, good point.
Sorry, I'm sorry.
Oh. That's weird. You know, I've never felt that I've had to inspect the donor chambers before.
Yeah, so maybe we do a quick look before we start. I'm so surprised it's stuck.
Well, you know, that donor chamber's been in there and soaking in water for almost a week. Well,
At least that one, the bubbles weren't such a problem. Good job.
usually it takes 5 minutes per.
I know.
It's 30 minutes for 3.
It's because you're out of observer. You know how that goes, right? So we're starting with 60 seconds.
Interesting. You can see as the water, it's been sitting in the water for a little while, that no matter what I do, there's a hole right there. So I'm going to have to get that centered over the donor chamber.
Right. Do you want to trim off where that hole is, or you can be able to see the hole?
Oh yeah.
Okay.
And actually what you can see that happens sometimes, it is actually starts to fold.
Yeah. So I hope you. Must be so the water in it drains out, and then you position, and then you can suck out the excess.
This is the PBS BSA solution.
Just fill the receptor chamber.
Well, the receptor chamber is actually probably largely full of deionized water. I couldn't see using BSA, PBS
Right.
in that.
And you're putting your little finger
Over the end of the tube.
Yeah. And then you screw in the other part. That tube's already filled, right?
Should be, and it's actually, the pump is running. And you can tap bubbles out, and because it's still flowing, you can, they would go up. I hold them up so that they go to the exit tube, and then they go right out. The BSA is definitely more, you have a much greater tendency for bubbles to form.
What flow rate are you using?
Right now it's at a tenth of a mil a minute, so 100 microliters a minute. 533, let's round it off. I'll pick one that looks like it should be good. Yeah.
I'll just do a couple more and let you finish in peace.
Yeah, that's... Wow.
So you have your little table set up ahead of time. All the cells, the little pieces, cutting board, clean samples, scratch dispersive, timer, the floating bath.
So I'm not providing very good narration to this.
That's fine, I'm getting enough, I think. I might just add some stuff later, or when we're looking at it, we could probably have you voice over.
You can definitely see that this one's folded in on, I mean, and that's not just a little bit of folding, that's kind of a ridge is formed.
And that's underneath?
Yep. Oops.
A little warm.
Now one thing is that the first thing I do in the morning
Just come and look at the bubbles again.
is well, hopefully I don't see any bubbles, but I pick up all the cells and I look through again. And once in a while there is a bubble, and I can just get that right out. Well,
That one sucked in a little, huh?
yep. Now, I'd be willing to argue that on virtually next to none of these would you ever have them perfectly flat.
Yeah.
So while we in fact say that the surface area is 0.66, whatever it is, there is a small variation that I don't think that there's anything we can actually do about. And it's definitely more dramatic the thinner we get. In the sense that if we use split thickness skin,
Right. 'Cause it's a little
it stays more rigid and it doesn't suck down as much than either the epidermal membrane or the stratum corneum. Now, a technical aspect of all this, for whoever will ever hear this, is finding the right focal length to be from here. Now, for the young folks with good eyes, not a problem. That was the nicest one so far.
Yeah, that wasn't nice.
Oh.
I will say this, you make it look easy, Wayne, and I know it's not when you split it.
Wow. And because you are very probably wondering what that little spinning of the cell is for, what happens when you, even though I take the insert plug and I turn it once or twice in my hand first, because then you're turning it counterclockwise to tighten it, I never get it perfect. So there's always a twist in the tubing. And so I get the twist out of the tubing by turning the cell, and what it helps is that it doesn't lower down and then catch on anything else. Okay. All that, and it was like less than 4 minutes.
That was a good one.
That was a really nice one. Murphy's Law dictates that that does not happen all the time. The thinner that the actual skin is that we get from them, the coiling sometimes becomes just almost unmanageable.
That would split pretty easily.
I don't know where that came from, but that was a little tiny hair. Now, I don't actually think that I included the syringe aspect in the method section.
Oh.
I might not have actually included that.
Yeah, that is kind of key. Now, when you come back in the morning, so obviously the skin is wet on the top. It's probably dry.
Probably
out.
not. Oh, it's wet now.
Right, but by morning.
No, and I do not leave the heater on overnight. The heater pump. So it's at ambient temperature for the next 12 hours.
Oh, okay. And wait a second.
Um,
All right. So that's going to be filling. Oh, yeah. Nice.
I mean, basically all I try and do is get a bubble up on the top. A convex or concave liquid, so that ideally that if there's liquid coming out of the end of the tube, then actually there shouldn't be any introduction of bubbles.
So now, when you use silicone rubber, do you follow essentially the same procedure? You don't have to separate and all that nonsense.
Oh, it's so trivial. You don't have to use this bath thing.
Oh, you just set it on.
Oh, you just put it
fill
right
with
on.
Do you set it? Do you fill it with water ahead of time? No.
No.
So
So I think in the general scheme of things, it probably
it doesn't matter.
doesn't matter at all.
Okay. But we should probably at least put it that way in. So are you covering up the holes or anything? You're just letting it drain, right?
I keep the little finger on the outflow tube always.
Oh, okay. I thought you said
I let it come out
the other side.
the other side usually what happens is if in fact there is any bubble that forms in the outlet tube, it just won't drain. It will not drain, and there are times where you have to exit you drain a cell basically with the syringe
Right.
to get it out,
I see.
to pop the bubble. And there are occasions where I have to put a syringe in this way too. It gets an air bubble and it doesn't. I knew there was something I was looking for.
That makes sense. Yeah, look my way.
So it's flowing at 100 microliters a minute now. I drop it down to like 10 microliters a minute overnight.
I mean, an hour.
A minute overnight.
10 microliters.
Just enough to keep a positive pressure flow,
And then what
and then we actually run it at 25.
I see, okay. So you're filling in 100, keep it overnight at 10, and you run it at 25.
The only reason I'm doing it at a higher thing
Oh, it's a lot
while I
easier.
do it is because it makes sure that there's actually a bubble forming of fluid, a droplet of fluid forming at the inlet tube
I see, right before you put it on.
before I put it on, so it reduces any probability that I introduce bubbles that way.
Right. Curled a little, huh?
Yep. It didn't release off of the
That thermos ring.
the probe.
Oh, I see. Yeah.
It also usually, when it curls under, it's usually curling under toward the epidermal side, so that it really helps that when you try and flatten it out, you put that at the bottom, try and flatten it out this way, and it stays with this stratum corneum at the top. The little wrist flick is to keep my sleeve out of the water. And this is a case where it looks like there was a bubble.
I see underneath, so you sucked out some water too.
And it still doesn't.
Oh, I see, it doesn't want to drain.
Nope. know if you can see the bubble that's in there. And now it's gone.